Lesson 3 is on angle relationships in polygons. So we're going to move on and we're going to look at a few different shapes. We've talked about triangles, we've talked about squares and rectangles, pentagons, hexagons. We're going to go all the way up to a decagon that has 10 sides. So how many diagonals can you draw from a single vertex in each polygon? There's kind of a cool concept here, and I think this lesson is sort of interesting, so I hope you do too. Some of the things we've already talked about is that this is a regular polygon, this equilateral triangle, because all of the sides would be the same length and all of the angles would be 60 degrees if it was an equilateral. So we've talked about that before. When we go up further into a pentagon, for example, this is a regular pentagon. So all of these sides would be the same length and all of the angles are the same. That's not true for every pentagon. Like I could draw a pentagon that looks like a house that has 5 sides as well, but maybe these corners are 90, whereas these are not, and this one's even different than those two. So pentagons can still have 5 sides, but they don't all have to be regular pentagons. So just to get started, we've done this before. We're looking at these exterior angles. You know that if the interior angle is 60, the exterior angle must be 120. So we've also discussed that 120 multiplied by 3 gives us 360, so that the exterior angles of a triangle add up to 360. So basically, we know a lot about triangles, so let's apply those to all of the other shapes. We also discussed quadrilaterals, but imagine doing this. What if we divided this square into 2 triangles? So we pick one vertex and we draw a diagonal across. All of these angles here add up to 180. And then this triangle as well adds up to 180. So 2 times 180 gives us 360 degrees. So the interior angles of a 4-sided figure of a quadrilateral add up to 360 degrees, which I know we've already talked about. We also talked about the fact that the exterior angles would also be 90 degrees each. So the exterior angles also add up to 360 degrees for a quadrilateral. What about a regular pentagon? What's going to happen there? So I know that these angles add up to 180 because that's a triangle and a triangle adds up to 180. And so do these 3, and then so do these as well. They all add up to 180 degrees. So together, if I add all of those up, I'm going to get what the interior angles of a pentagon add up to. So I would do 3 times 180 because there are 3 triangles inside, and I get 540 degrees. What if I want to know how big each angle is inside a pentagon? So I know that they all add up to 540, but now when I look at this pentagon, I want to know the measure of the interior angles. So if I do 540 and I divide it by 5, because there's 5 angles in a pentagon, I get 108. So each one of these corners in a pentagon, in a regular pentagon, are 108 degrees. So what does that mean for the exterior angle? So remember, if this is a supplementary angle, 180 minus 108, I get 72 degrees. So the exterior angles are all 72 degrees. If each exterior angle is 72 and I have 5 of them, what does that add up to? So 5 times 72 degrees is 360. So we're seeing that that number is consistent. The exterior angles here add up to 360 again. So I think it's going to be a safe assumption that for any shape, isn't that interesting? For any shape, the exterior angles add up to 360 degrees. So let's look at a hexagon. If somebody says, hey, what do the angles inside a regular hexagon add up to? You don't have to memorize all of these. 180, 360, 540. Some of you who skateboard or snowboard or ski, maybe you're recognizing these angle measurements as rotations when you're skateboarding or snowboarding. So people will be like, oh, I did a 360 and then I did a 540, and you kind of might recognize these numbers, and you might know the next one if you're into gymnastics or something like that where you're doing a lot of rotations. A hexagon. So if you have no idea what the next one might be, If I pick one common vertex, so it looks like I end up with 4 triangles. So I know that 4 times 180 is 720. So right away I can say, oh, that's 720 degrees. The inside angles all add up to 720 degrees. How big is each one though? If I want to know how big each interior angle is, I would have to take 720, and I don't divide by 4, I divide by how many interior angles there are. So if there's a hexagon has 6 sides, I divide by 6, and I get 120 degrees. So on the inside here, each interior angle would be 120 degrees. And if I start thinking about the exterior angles, I think you can see if the inside's 120, the outside has to be 60, because together they have to equal 180. So each exterior angle would be 60 degrees. And I know that there are 6 of them, and 6 times 60 is 360 again. So that's our conclusion. Our exterior angles again add to 360. This seems like an awful lot of work, right? I'm sure you're thinking, wow, am I going to do that every time? This is so much work. What I want you to notice is the pattern. So exterior angles always add up to 360. On the inside though, if I had 4 sides, if this was a 4-sided figure, I ended up with 2 triangles. If I had a 5-sided figure, that was 3 triangles, or 3 times 180. If I had a 6-sided figure, I ended up with 4 triangles inside, or 4 times 180. So in order to figure this out without drawing all of these triangles, if it's a 6-sided figure, I have 4 triangles, it's always 2 less. So if I had a 21-sided figure, that would be kind of hard to draw, but a 21-sided figure, inside I would be able to get 19 triangles. So if we look at a heptagon has 7 sides. I'm not going to keep making you draw all of these triangles across. If you did though, you'd pick a common vertex and you would want to draw all of the diagonals across to create triangles. If you had 7 sides, 5 triangles. So what does a 7-sided figure add up to? What does a heptagon add up to? I don't expect that you know that right off the bat. I think you would do, oh wait, 5 times 180 is 900. So this would add up to 900 degrees on the inside, all of these angles for a heptagon or a 7-sided figure. How big would each angle be? So each angle, if I did 900, I divide it by 7 though, because there are 7 interior angles. I'm going to get a decimal this time. I get 128.6. And then if I look at my exterior angles, there's a couple of ways I can figure this out. One is by using this supplementary angle property. If I take 180 and I take away 128.6, I get 51.4. So the exterior angles are all 51.4 degrees. Another way that I could have gotten that number, at the 51.4, I could also take what I know already. I know that the exterior angles add up to 360 degrees. I know that there's 7 of them because it's a heptagon. When I just take 360 and divide by 7, I also get 51.4. So a regular octagon, let's try and do a little less work this time. A regular octagon has 8 sides. 8 sides means there would be 6 triangles. 6 times 180 is 1080 or a 1080. So then how big would each one be? How big would each measurement be? We could do 1080, and we divide it by how many there are. So if it's an octagon, there's 8. So we divide by the number of sides. And that's 135 degrees. So each interior angle is 135 degrees. What about the exterior angles? So if we knew the interior angle is 135, we could subtract that from 180 to get the exterior angle. Another way to get the exterior angles are just to divide 360 by the number of sides. So that's 45. So I know each exterior angle must be 45 degrees. What about a nonagon? So if we had 9 sides, we would have to take off 2. So 9 sides, that'd be 7 triangles inside. So 7 times 180 is 1,260. What is the measure of each interior angle, if it's a regular nonagon, we would take 1260 and divide it by 9, because there are 9 angles inside of a 9-sided figure, and we get 140 degrees. If we're thinking about the exterior angles, obviously you kind of notice that that would be 40, because 140 plus 40 would be 180. But let's say you didn't already know that the interior angle was 140, you could do 360 divided by 9, and that gives us 40. So we know that each exterior angle is 40 degrees. The last shape here, a decagon, again, 10 sides, decagon. I could pick one common vertex and I could start drawing my triangles across, and I would end up with 8 triangles. So 8 times 180, get a 1440. How big is each interior angle of a regular decagon? 1440 divided by 10 is just 144. Exterior angles, fastest way to do that, 360 divided by 10, because we have 10 sides, is just 36. So that should also make sense here. We'd have an exterior angle of 36 degrees.